Hello everyone, welcome back to my channel InfoSec Lab. Today we are going to talk about NoSQL injection. Now in recent years, the use of non-relational database like MongoDB has grown significantly, which explains why non-relational database has become main target for many threat actors. In today's stream, we're going to learn about the basics of NoSQL, what they are and how they store database. We also learn about different types of NoSQL injections and how to practically exploit those vulnerabilities. So what's NoSQL? Much like MySQL, MariaDB, or PostgreSQL, MongoDB is another database where you can store data in an ordered way. MongoDB allows you to retrieve subsets of data in a quick and structured form. If you're familiar with relational databases, you can assume MongoDB works similarly to any other database. The major exception is that the information isn't stored in tables but rather in documents. You can think of documents as simple dictionary structure where key value pairs are stored. In a way, they are very similar to what you would call a record on traditional relational database, but the information is just stored differently. For example, let's say we're creating a web application for our HR department. We would like to store basic employee information. You would then create a document for each employee containing the data in the format that looks like this. We have ID, we have object IDs, we have username, first name, last name, email address, age, etc. As you can see, documents in MongoDB are stored in an associated array with an arbitrary number of fields. MongoDB allows you to group multiple documents with a similar function together in hierarchy structure called collections for organizational purposes. Collections are the equivalent of tables in relational databases. Continuing with our HR sample, all the employees' documents would be conveniently grouped into a collection called people as shown in the diagram. Okay, we have the people collection right here, and we have the documents. Multiple collections are finally grouped into databases, which is the highest hierarchical elements in MongoDB. In relational databases, the database concept groups tables together. In MongoDB, it groups related collections. Okay. Querying the database. As with any database, a special language is used to retrieve information from the database. Just like relational databases use some variant of SQL, non-relational databases such as MongoDB uses NoSQL. In general terms, NoSQL refers to any ways of querying a database that is not SQL, meaning it may vary depending on the database used. With MongoDB, queries use a structure associated array that contains groups of criteria to be met to filter the information. These filters offer similar functionality to a where clause in SQL, offer operators the abilities to build complex queries if needed. Again. With MongoDB, queries use a structure associated array that contains groups of criteria to be met to filter the information. These filters will offer a similar functionality to a where clause in SQL and offer operators the ability to build complex queries if needed. To better understand NoSQL queries, let's start by assuming we have a database with a collection of people containing the following three documents. If we want to build a filter so that only documents where the last name is Sandler, this is how we retrieve it. Last name, Sandler. As a result, this query is only retrieved the second document, which is this one. If we want to filter the documents where the gender is male and the last name is Phillips, we'll have the following filter: gender, male, last name Phillips. This would only return the first document right here, okay? If we want to retrieve all documents where the age is less than 50, we can use the following filter: age less than 50. This will return second and third documents. Notice we are using the less than operator in a nested array. Operators allow for more complex filters by nesting conditions. A complete reference of possible operators can be found on the following link. Say this is the link to a MongoDB. MongoDB.com docs manual reference operation. Okay. What is the group of documents in MongoDB known as collection? Using the MongoDB operator reference, what operator is used to filter data where a field isn't equal to a given value? Isn't equal. Not equal. Following the example of the 3 documents given before, how many documents would return by the following filter? The gender is not equal female, meaning it's male. The age is greater than 65. Okay, age 42, 65. Do have equal, greater or equal? No, it's greater than 65. Now this one is 65, so return 0. Doesn't matter the gender. NoSQL injection. First, we start the virtual machine. Okay, and then we start an attack box. Can we start both? Injection is injection. While it may seem complex to think about NoSQL injection, when we boil down injection attack to their very essence, we can understand the similarities between the SQL injection and NoSQL injection. The root cause of injection attack is that improper concatenations of untrusted user input into a command that allow an attacker to alter the command itself. With SQL injection, the most common approach is to inject a single auditable code that terminates the current data concatenation and allows the attacker to modify the query. The same approach applies to NoSQL injection. If untrusted user input is directly added to the query, we have the opportunity to modify the query itself. However, with NoSQL injection, even if we can't escape the current query, we still have the opportunity to manipulate the query itself. Therefore, there are two main types of NoSQL injection. The syntax injection. This is similar to SQL injection, where we have the ability to break out the query and inject our own payload. The key difference to SQL injection is the syntax used to perform the injection attack. Operator injection. Even if we can't break out the query, we could potentially inject a NoSQL query operator that manipulates the query's behavior, allowing us to stage attacks such as authentication bypasses. Alright, in this room, our main focus is going to be operator injection and the different ways it can be leveraged. This is because it's not common to find a syntax injection cases, as most libraries used to create the queries apply filters that prevent you from injecting into the syntax. However, since user input can vary, these same features can offer vulnerable to operator injection. However, we'll cover a syntax injection example at the end of the room. Alright. How to inject NoSQL. When looking at how NoSQL filters are built, by passing them to inject any payload might look impossible, as they rely on creating a structural array. Unlike SQL injection, where queries were normally built on simple string concatenation, NoSQL queries built on requires nested associated arrays. From an attacker's standpoint, this means that to inject NoSQL, one must be able to inject arrays into the applications. Luckily for us, many server-side programming languages allow parsing arrays variables by using special syntax on the query string of a HTTP request. For the purpose of this example, we focus on the code written in PHP for a simple login page. Okay, the web application is making a query to MongoDB using the MyApp database and login collections. Okay. Requesting any documents that passes the filter username equals to user, password equal to pass, where both user and pass are obtained directly from the HTTP post request or parameters. Let's take a look at how we can leverage operator injection in order to bypass the authentication. If somehow we could send an array to the user and the pass variables with the following contents, user not equals, password not equal, the resulting filter would end up looking like this. Username is not equal to XXX and password is not equal to YYY. We could trick the database into returning any document where the username isn't equal to XXX and the password isn't equal to YYYY. This would probably return all documents in the login collections. As a result, the application would assume a correct login was performed and let us into the application with the privileges of the user corresponding to the first document obtained on the database. The problem that remains unsolved is how to pass an array as a post request. It turns out that PHP and many other languages allow you to pass an array by using the following notation on the post request body. User not equals and then XXX. Okay, so let's fire up burp sweep. Okay. Need this one. We also need burp sweep. What type of NoSQL injection is similar to normal SQL injection? That's syntax. What types of NoSQL injections allow you to modify the behavior of the query even if you can't escape the syntax? Operator. Operator injection by passing the login script. HTTP 10.10.115.212. Okay, we try to log in and send a request to burp. The original capture login request looks like this. Okay, we now proceed to intercept another login request and modify the user and pass variables to send the desired array. Not equals, not equals. This forces the database to return all user documents, and as a result, we are finally logged in as the application. Logged into the application. Okay, so let's try. We also have target, proxy, intercept is on. Okay, we send this to repeater. I'm going to open this in a new tab. Make it larger so it's easier for you to see. I hope you can see. How do I make it larger? User interface, sidebar, display. Okay, the font size right here. Make it 16. There we go. Much better. Let's keep it this way. though this one's still too little, too small to see. But anyways, so this is the original request. As we know, in order to modify the payload, we use the any operator. Can I zoom? So over here is not equal. The same over here, we use not equal. Send it. Follow redirection. Follow redirection one more time. And we got 200 error, 200. Okay, let's turn up the intercept. Doesn't work. Let's try one more time. Forward. This one. Okay, we log in as the admin. Cool. When bypassing the login screen using the not operator, not equal operator, what's the email address of a user that you logged in as? This one, admin nosql.in. Operator injection. Logging in as other users. Extend the machine. Logging in as other users. We have managed to bypass the application's login page, but with the former technique, we can only log in as the first user returned by the database by making use of the not in operator. We are going to modify our payload so that we can control which user we want to obtain. First, the not in operator allows us to create a filter by specifying criteria where the desired document have some fields not in the list of values. If we want to log in as any user except for the user admin, we could modify our payload. Looks like this. Not in OK with a square bracket. So it looks, oh, because that's a list, so we have to specify this one right here. Alright. This will translate into the filter that has the following structure. Username not in the list of values. And the first value is admin, so this syntax, this structure tells the database to return any user from whom the username is an admin, and the password isn't some random strings. As a result, we are now granted access to another user account. Notice that not in operator receives a list of values to ignore. We can continue to expand the list by adjusting our payload as follows. So in this case, we have another user named Jude in the system. Let's say we have found that user. Then we add to the list. We don't want to log in as admin. We don't want to log in as Jude either. So we specify these two username in this. Okay, so that makes sense. So how many users are there in total? No, let's try. It steps up. So we use not in. First one is admin. Okay, let's send it forward. No, this one. Oh my god. Let's try again. Oh, we have to this one too. And the password is not equal. Forward. Okay, so we have another user. Petro. Forgot to write out. So admin mean no SQL.in web Petro P Collins at no SQL.in. Okay, what else do we have? Except nope. Not copy. Not. Let's double check. Okay. Looks good. What is it? Web user Chan and email address. And okay, John. Let's continue this one. Secret. error. So we got error. All right, so how many users we got? 4. Okay, we got 4 users. This is a user that start with a P. True. True. Okay, operator injection extracting users' passwords. Okay, at this point we have access to all the accounts of the application. However, it is important to try to extract actual passwords used, as they might be reused in other services. To accomplish this, we will abuse the regex operation to ask a series of questions to the server that allow us to recover the password by a process that resembles playing the game Hangman. First, let's take one of the users discovered before we try. And try to guess the length of his password. We'll be using the payload to do that. So we are doing the admin. So we see we use the admin password, we use the regex. Notice that we're asking a database if there is a user with the username admin and password matches the regex right here. This basically represents a wildcard word of length 7. Since the server responds with a login error, we know the password length of the user admin isn't 7. After some trial and errors, we finally arrived at the correct answers. So here, the password of admin is 5 characters. We now know the password for the user admin has length of 5. Now, to figure out the actual content, we modify our payload as follows. So basically, if we get the correct regex, the location is going to be something else that's not error. Alright. And the syntax is user equals admin password. We use the regex. Okay. Now we know the password has a length of 5. We can figure out the actual content by modifying the payload. We are now working with regex of 5 as a single letter C plus 4 dots, matching the discovered password length, and asking if the admin's password matches the regex C, which means that it starts with lower C, followed by a 4 characters. Since the server responds with an invalid login, we now know the first letter of the password can't be C, lowercase. Continue iterating over available characters until we get a successful response from the server. Oh, okay. Okay, let's try that. So we have admin and we have server password. Now we send this one to repeater. We're going to use the regex. Equal. Excuse me. Is it correct? Yeah. Now we can easily send this to intruder, but since the length is 5, we just have to confirm that. It's not 5? Okay. Alright, let's send it to intruder then. Just want to make sure I use the correct operator regex. Okay. This one, brute force. Simplest numbers from can't be 0, 1 to 20. Yeah, let's make it quick. We're going to take a look at the location. So in the payload right here, we have to specify grep. We have to use the grep extract right here, this function right here. Add fetch a response to see a sample response. We're going to set this field right here and add it. Now we can start the brute force. Okay, so we know the admin has a password of 8. Cool. No discard. Now we know it has 8 characters. Now we're going to do 1, 2, 3, 4, 5, 6, 7. And we're going to brute force add this one. We have to modify the payload. Brute force. Okay, we're going to add the uppercase. And everything should be the same. Start the attack. Continue. Okay, first one is 0. Wait, what? Can't be. These are just a benchmark. Okay, first one is A, so that's correct. We're going to continue. Well, this one is A, so continue this one. Add. Same thing, start. I would say it's admin something. ADMIN, that's 5. So 8 characters, admin 1, 2, 3. Yeah. I'm gonna guess. Admin. These are 5 characters long. Let's confirm this one first. Alright, so I know it's gonna take a while to actually get the password. But eventually in real world, when you perform a pen test, this is actually what we have to do. If you want, you can write a Python script to actually run faster. Example in the menu one. So I'm going to be going through that exercise and see how to do it. But it's going to be in a future video. Have you got anything? My guess is the password is 123. Yeah. Let's try that. Alright, so we're logged in. Cool. Okay, so basically the same concepts for any other users. You can try what is John's password. You can try the same thing. With John, the same concept. First, you have to enumerate the length of the password, and then you have to enumerate each character of the password in each position until you find and you can fully extract the password. And since I've done this before, I know the password is going to be cool pass 123. No. 2, 4. Okay. It's not? Okay, now I have to prove false again. Set John random password intercept. Send this one to intruder. It's going to be the same thing. Copy everything here. Paste it here. Oh. Regex. User John. Simplest. From 1 to 20. Hmm. From 1 to 20. Same thing. We're going to look for the values of location right here. Add it. And let's see how long the password is. Okay, child password has 8 characters. Now we have to go back and try to brute force one of those. Skirt. One, two, 3, 4, 5, 6, 7. Modify the payload. This one. Okay, let me look up my note if I have the password, because it's going to take a long time. There's something wrong. Oh, this explains why. My bad. Okay, so basically the concept behind this is we have to go and extract each of the character from the password from each position until we fully retrieve the password of John. So in this case, the first character is going to be still hasn't found. Well, according to my note, it's going to be the first character is going to be number 1. Yep, right here. All right, we can stop the attack for now. Discard it. And once we find it, we continue with the second position. Now I know the password is going to be all numbers, so I'm just going to be remove everything to save time. But in reality, we have to go through all of the characters and numbers, and sometimes we have to include the special characters too. second position is going to be 0. And we keep doing that until we fully recover John's password, which is 105843112. Okay, one of the users seems to be using his password for many services. Find which one and connect through SSH to retrieve the final flag. Again, the same concept, we have the other two, which is petrol and secret. And I think one of those has the password cool pass, which I was trying earlier, but unsuccessful. So let's try one more time. Proxy intercept is up. What was the IP address right here? Can we zoom in? Yes. So SSH. Let's try John. What is John's password? Okay, John did not reuse his password. So we're going to try petrol. And the password after the enumeration is going to be cool pass 123. And we locked it. Add the flag. All right, so let me see, hold on a second. So that's how we use the regex operator to enumerate the length of the password and then fully exfiltrate the password one by one using the same regex operator. Okay, moving on next, syntax injection. Now, as mentioned earlier, we're going to cover the syntax injection at the end of this room. So now that we have covered operator injection, let's take a look at the syntax one. Python application is running to allow you to receive the email address on any username that is provided. To use it, we're going to use the terminal right here. SSH syntax 10.10.115.212. Password is syntax. Once authenticated, you can provide username as input. Start by simply providing admin. Okay, and we're locked out. We can start a test for syntax injection by simply injecting a single code character. Admin, which will result in the error seen in the response below. Yep. The following line of the error message shows that there is syntax injection. For X in my column, find where this username is equal. Where is it? Right here. So it's going to be the very first few lines right here. For X in my code, I'll find where username is. All right. Like the traditional SQL injection, this is injectable, meaning that we can actually inject malicious, meaning we can actually break out of this query to inject another payload. We can see that the username variable is directly concatenated to the query string and that a JavaScript function is being executed to find a command, allowing us to inject into the syntax. In this case, we have a verbose error messages to give us an indication that injection is possible. However, even without verbose error messages, we could test for syntax injection by providing both false or true conditions and seeing what the output differs. Okay, let's try that. Okay, syntax. We can try this one. Connection closes. We can try this one. And we get the email. Exploiting syntax injection. Now that we have confirmed that syntax condition injection, we can leverage this injection point to dump all email addresses. To do this, we want to ensure that the testing statement of the condition always evaluates to true. As we're injecting into the JavaScript, we can use the payload, this one, and let's use this one to disclose sensitive information. And boom, and we were able to retrieve all the email addresses in the database. The exception to the rule, it is worth noting that for the syntax injection to occur, the developer has to create custom JavaScript queries. The same function could be performed using the built-in features functions where username would return the same results but not be vulnerable to injection. As such, syntax injection is rare to find, as it means that developers are not using the built-in functions and filters. While some complex query might require direct JavaScript, it is always recommended to avoid this to prevent syntax injection. The example shown above is not for MongoDB, but for other NoSQL solutions, similar syntax injection cases may exist. But the actual syntax will be different. What common character is used to test for injection in both SQL and NoSQL solution? This one, single quotation mark. What's the email value for the super secret user return in the last entry? Okay, this one. We actually found it at the beginning of the root, so it doesn't really matter. Conclusion, defenses. To defend against NoSQL injection attacks, the key remediation is to ensure that there isn't any confusion between what is the query and what is user input. This can be resolved by making the user parameterized queries, which split the query command and user input, meaning that the engine cannot be confused. Furthermore, the built-in functions and features of the NoSQL solution should always be used to avoid syntax injection. Lastly, input validation and sanitization can also be used to filter for syntax and operator characters and remove them. Alright, that's it for today's video. If you have any questions, let me know. It's a simple and easy to understand, but still for a lot of people, it may be a little bit confusing. Thank you very much and see you next time. Bye.